Good morning. My name is Dakota James, and this is my video explanation of hydrophilic molecules versus hydrophobic molecules. We'll start with hydrophilic. Hydrophilic means water loving, and hydrophobic means water fearing. So why are some substances hydrophilic? Those substances are polar, which means the electrons favor one side of the molecule, allowing that molecule to have a either semi-positive or semi-negative charge. This allows those electrons to attach to the semi-negative side of the H2O molecule, being water. So it allows the hydrophilic substance to bind with the water. This allows the water to act as a solvent and allows the hydrophilic molecule to be evenly dispersed throughout the water. Some examples of hydrophilic molecules are sugar and enzymes. Then with your hydrophobic, meaning water-fearing molecules, they are nonpolar. So the electrons are evenly distributed throughout the molecule, thus there is no charge to attract to the semi-negative H2O. So in the hydrophobic molecules, they will tend to clump up and bind to themselves rather than binding or diffusing with water. Some examples of hydrophilic molecules are fats, lipids, oils. The hydrophilic molecules help create barriers, and one of the biggest examples of this is in the cell membrane, where actually we can see examples of hydrophilic and hydrophobic, where your hydrophilic heads attract the water, and then the tails in the membrane are hydrophobic. This allows the membrane to span both sides of water and create the barrier. Another example we can see is here when we look at a hydrophobic motor oil molecule, and then a hydrophilic sugar glucose molecule and a hydrophobic oil molecule. You can see how all the electrons are shared equally between the carbon and the hydrogens in the oil. They create these long chains, and then in the hydrophilic glucose, you can see how the electrons are not shared equally, allowing the glucose molecule to attach to the H2O.